Right guys, we're at the final thing really to do. So I've got the motor back on, wired up, so that's all ready. I've trimmed some of the gasket around the sides. I've refitted the front plate, refitted the gear shift levers. I've checked through all the gears to make sure they all engage okay, and they do. So the last thing now to do is fill this up with oil, and I needed to order some because I didn't have any of the right grade, and that's turned up. The problem I've got is I've got nothing. It's a tiny hole. It's about 10, 11 probably mil diameter, inside diameter hole in the top, the filling hole, and I don't have a funnel small enough to go in there apart from a really tiny one, which is, I'd be all day, and the oil's probably too thick to go through it. So what I've done is adapted the funnel that I have got, which has had a good clean out. So this is the one that I used earlier for draining and whatnot, so it's had a good wipe out and a good degrease. And what I've done is fitted to the end of that just a bit of garden hose, and I've managed to stretch it, just warmed it up and stretched it over the funnel at the bottom, so that's pretty good. And then, I don't know if you can see there, I've just cut a tiny V out of it, and hopefully that'll be enough to allow me to poke it in the hole at the top, and then we'll give that a go and see if that enables us to get the oil in. So we'll do that now. Let's see if this is going to work. It looks like it is. Not too bad. So what's going in, it calls actually on the label here for LAN32, which is a 32 grade hydraulic. I can't get that, but I can get ISO 32, which is an equivalent. So this should be the equivalent. So we'll give this a go. Looking good so far. I've refitted the sump plug, by the way, just in case any of you were wondering. And what I did do was I put a neodymium magnet on top of it, so that when it comes to oil change time, hopefully any loose metallic particles will be captured by the magnet, and then when I remove the sump plug to do an oil change in the future, I should be able to remove all the particles off the sump plug off the magnet. So I'm just looking at the sight glass. I think this is about 2.5 litres it holds, so it should be half of this tub. Nothing on the sight glass yet. Still nothing on the sight glass. It's not pouring out anywhere, so here we go. Just coming on the sight glass now. Just under half. That's bang on halfway. Now when it came it was just over half, which is there. That was drama free. Useful little tip. Get rid of the gloves now. This filling nut here has got a breather in it as well, which is obviously for when it's running. So that's it, that's us full of oil. Now what I intend to do now is run the machine in each gear for 10-15 minutes, and I'm just going to keep feeling the spindle temperature as we go, just to see what that feels like, and obviously to try and run the bearings in a little bit as well, because everything's brand new. So we'll do that now. Just unplug the lathe on the transformer and plug the mill in, put it on the mill setting, power up. So the moment of truth. So we're going to start in low gear, lowest spindle speed, and interestingly that's much better than it used to be. Much freer and easier gear changes since I've deburred all of the linkages and everything, and where the actual brass pieces have been deburred, and it's just much easier. So the moment of truth, it's either going to make a very horrible noise or it's going to be okay. So this is live. It's going to make no noise at all, because no, we switched on, we powered up. Maybe I've not hit that switch. Still nothing. Ah, that was in the neutral position. Let's have another go. Oh, what a difference in noise. That is a different machine. Okay, so I don't think you guys need to watch this run for 15 minutes in each speed, but I'll bring you back if there's any update. Alright guys, that's done 10 minutes in each speed range. So, and the speed ranges are 95 revs a minute, 170, 280, 540, 960 and 1600. And what I've been doing throughout that time is feeling the temperature of the spindle here at the bottom, feeling the temperature at each stop point up inside the taper, up inside the Morse taper in the nose of the spindle. I've been feeling the temperature of the top bearing up here, which isn't the top bearing in the spindle, but it's the top bearing on the final drive. I've been feeling the temperature of the motor, feeling the temperature of the head itself, the casting, to see whether that's getting warm or whatever. And I've also been using a listening stick, and in this case it's a file, and basically what I've been doing is sticking that on the side of the head, and you stick your ear on the other end and you can actually hear what's going on inside the head, if there's any clunking or any funny noises. And the good news is, after all that, this has got warm inside the spindle there at the nose. It's probably hard to say. It's probably 30 degrees C, so that's an hour's running and 10 minutes at the highest speed with no load. Obviously there's no cutting load or anything, but that's probably 30 degrees ish, 32, 33 maybe, it's hard to say, but it's somewhere in that sort of range. So I'm happy with that. I think that's gone well. I think we're going to wrap this series of videos up at that, and I think we'll call that a success. What else I've done in the background is I've fitted my new spindle locks. I know you can't see them, but the new sort of quick release locks, I fitted those as well to the mill. So we're back in business, I think. Obviously we need to try this with a cut on, but in terms of the rebuild, I'm really happy with that. It's quiet now, and I think that's been a useful few hours spent tidying that up. So, one last thing I didn't say, what else I was checking for as well was oil leaks from around the seal here, and also from the sump plug, and again, great, there's no oil leaks anywhere, so the gasket sealant stuff has worked well. Okay, we're just going to do some quick geometry checks now, just to see, now the rebuild's complete, how the spindle's running. So what I've got there, you'll see I've just got my clock on the clock stand off the surface plate up inside the spindle in the taper, and I've zeroed that out. So I'll just bring you in closer on the clock face itself. Hopefully you'll be able to see it. So each graduation on this clock is 5/10 of a thou. Just get you in. Is that going to focus? Right, there we go. That's looking good. So I'll just start the mill up at that on a slow speed. Just adjust the axis so that it's back on zero, because there's a bit of parallax error going on because of the, well, I've got the camera. There we go. So best I can measure that, looking at that, it's not a full division, it's probably 3/4 of a division, so we've probably got 3/10 run out in that taper, and the way that's running suggests that that's either distortion in that taper or the way the taper was machined, as opposed to the whole spindle running out by that amount, because there seems to be a bulge in it in one place. So pretty good, fairly happy with that. What I'm going to do now to stop that is I've got a ground test bar with a Morse taper 3 on the back, so we'll put that in a sleeve up to Morse taper 4, put that in the spindle, and we'll do some run out checks at the end of that test bar, and also some a check of the quill in the XZ axis and possibly in the YZ axis, just to see how true that's running. So I'll just bring you back in a moment once we've got that set up in the spindle. Right then guys, you'll see there I've fitted a ground test bar into the spindle. It's Morse taper 3, and I've fitted that into a Morse taper 3 to 4 adapter that came with the machine. Now I would imagine that's of Chinese origin, so I don't really know how good or bad that is, but what we're going to do now is put the clock onto the bottom of the test bar and just see what the run out's like at that distance. And that distance is, bear with me, I'll just get a rule. So from the spindle nose we're at 170mm stick out there. So I'm just going to try and work around the tripod, so bear with me. So we'll just bring that up to somewhere near zero, and then we'll have a look to see where the high point is, so we know we're on centre. There we go. And then we'll start the mill up. zoom you in. So I'll just reposition that around about 0. That's interesting, you'll see there's a bit of vibration on the needle there. This is an issue I've got with my transformer. If I put this under load now, you'll hear the noise change. So that's just some noise that you get from the motor as a result of the transformer. I mean, that's not under any real load, that's just me gently gripping the bar. But anyway, best I can measure that, we've got between 2 and 3 divisions on the clock there, so, and they're 5/10 a division, so we're talking about somewhere between 1 thou and 1 thou and a half run out at 170mm away from the spindle. So that's not too bad. It's not brilliant, but putting it into perspective, you know, in industry, in some of the companies that I've worked at, when you're specifying a high precision 5-axis machine tool, typically something of that type, CNC, on a 300mm test bar, the limit is normally about 15 microns, which is 7/10 of a thou, which would be 1.5 divisions on this clock. So, and I know I'm not over 300mm there, we're over 170, but even so, that's not too bad. And again, I don't know how much of that's coming from the Morse taper sleeve that I've got in there. So what we're going to do now, and I'll try not to get my arms in the way, I'm just going to drop the spindle down now and just see in a static mode and see what change there is. I mean, that's perfect. It's moved there because I bumped it at the end. There's a bit of movement, but largely top and bottom that's 0. So that tells me that there's no, in the quill itself, there's no movement that there shouldn't be. What I'm also going to try and do is see if I can get on the y-axis. I don't know if I can move the y-axis far enough forward to do this. We'll just try it, just bear with me. Let me zoom out so you can see what I'm up to. Other way. Yeah, we should be able to get on that. That's on centre line there. I'm just going to put that onto 0, and then I realise you're not going to be able to see, just bear with me, I'll bring you back. Alright guys, we've got it set in the YZ plane now. So I've touched on, I've found the highest point and I've zeroed in on the clock. So if I just zoom you in, hopefully. So I've zoomed in on the clock now. Again, each division is 5/10 of a thou. So you can see there we're pretty much 0. It does move slightly in the middle by a couple of graduations, so there's probably about 1 thou of movement in there. The other test I've done, and this leads me to believe that I think I'm possibly going to need to, after I've run the mill for a while, maybe tighten up the taper roller bearings that I've put in. I've done what they call a lost motion test, and that's where you basically pull one way on the test bar, and you can see that's moved and it's gone back to 0. And if you push it the other way, there's about 2 graduations worth of lost motion in there, so there's about 1,000 worth of lost motion, and that's 1,000 multiplied by 170 millimeters away from the spindle, so that error in the bearing itself is absolutely tiny. I'm not going to lose any sleep over that. That's a really small amount, and you'd expect a certain amount of lost motion in a spindle anyway, where you've got bearings. I'm really pleased with it. You know, it's running square, it's running true, it's running good as the quill goes up and down. My run out at the bottom of that is, as I said, 1,000 roughly. I don't think for a hobby mill, especially an import one, I don't really think those numbers could be much better, to be honest with you. Even if we'd spent time trying to scrape in the bearings, you know, at the taper roller bearings at each end, that is really good. So we'll see how it performs. You know, the true test of this, of course, is when you put a cut on. So we'll see how it performs with a cut on, but for now I'm really happy with that. The last and final test I'm now going to do is I'm going to take the vise off the machine and I'm going to tram the head back in, just to make sure that through all the work that I've done that I've not gone out of tram anywhere. So I'll do that check. I'll not do that on camera. There's 1,000,001 videos on YouTube showing you how to tram a head in, so I'll just do a double check on that, and that really brings us to the end of the mill rebuild. So the next time hopefully you'll see this in action, we'll be cutting, I think the next project's going to be tailstock die holder, and I've got some slot milling to do on that, so the next time we'll use this in anger will be on that project. So yeah, we'll wrap this series up at that. Hope that's been useful to anybody else who's, I've had 1 or 2 comments from several people who've either bought a similar machine or thinking of buying a similar machine, and they've sort of said that it will be a useful reference for them, so I hope it is useful. I know, Robert, you're doing a similar thing with your machine that you bought, which is exactly the same model as this from Cormak, so I hope that's useful for you, Robert, as well. We'll wrap the series up at that. So thanks for subscribing, thanks for watching. If you're watching and you haven't subscribed yet, please do, because it'll help the channel grow. And we'll catch you all on another video very shortly, when we'll be back into making swarf again and back into the projects.